Hello everyone. In this lecture, we will discuss the exponential distribution. It is a continuous type distribution. With the probability function given by f of x is equal to some alpha e to the power minus alpha x. Alpha is positive and 0 alpha is negative. This you may 0 also include here. Now this alpha is a parameter here. Alpha is a positive, right? Otherwise this negative sign will have no meaning. So alpha is positive and this alpha is a parameter here. Alpha is a parameter here. And then x here is the exponential variate. This is the exponential variate. Now coming to some properties, because of this presence of this minus sign, this distribution is sometimes also called this is sometimes also called negative exponential distribution. However, it is usually called exponential distribution. Right? It is a continuous distribution. It is a continuous distribution, type distribution. Why? Because if I see this f of x is positive here, non-negative here, right? Alpha e to the power minus alpha x coming to the denominator 1 by e to the power alpha x. Alpha is positive and it will be positive. Now the main important thing is that we have to see this integral minus infinity to infinity fx dx is equal to 1. It is most important to see it here. So now if you see here, you can split this integral. It is minus infinity to 0 plus integral 0 to infinity f dx. So minus infinity to 0, this integral will not work because it is negative interval, it is 0. So it will work on 0 to infinity, and within 0 to infinity the probability function is alpha e to the power minus alpha x dx. If you integrate it, so alpha being constant taken out, e to the power minus alpha x, the integration is e to the power minus alpha x, and this minus alpha is divided here and the limit is 0 to infinity. So this is my minus 1 into e to the power minus infinity is 0 and it is 1. So this is 1. So therefore it is guaranteed that it is a continuous type distribution. Now if you think of its distribution function, probability distribution function, or what we call it PDF, probability distribution function, right? Or also we call it cumulative distributive function, CDF, right? Cumulative distribution function. So what is the cumulative distribution function here? F of x at some t, say, means it is probability of x up to some t, means you need to integrate from the starting minus infinity up to t, here probability function fx dx. So you split it here, it is minus infinity to 0 plus here 0 to t f of x dt. So now here it is 0 according to the given distribution. Now it is here integral 0 to t, here f of x is alpha e to the power minus alpha x dx. If you integrate it, it is here alpha by minus alpha e to the power minus alpha x 0 to t. So this is equal to minus 1 e to the power minus alpha t minus 1. So this is 1 minus 1 minus e to the power minus alpha t. So what happens to my fx here? So I can say my fx here is 1 minus e to the power minus alpha x when x greater than is equal to 0, right? And I can say 0 when x less than 0. So this is the probability distribution function here, right? And by definition, in lieu of this definition, this is 0. So now coming to the mean and variance of this distribution. Mean and variance of this distribution. What is your mean mu? Your mean mu is expectation of x. So this is equal to integral minus infinity to infinity x into fx dx, and this integral will work on 0 to infinity. It is x into the value of fx is alpha e to the power minus alpha x dx. So this is alpha taken out and we apply integration by parts over here. It is first integral second e to the power minus alpha x by minus alpha. Put a negative sign here and it is here derivative of this is 1 and it is e to the power minus alpha x by minus alpha into alpha square. So from the limit 0 to infinity. So within this limit 0 to infinity, this integral will vanish because e to the power minus alpha x is 0 and 0 into something is 0 here. So it is minus of alpha divided by alpha square, and putting e to the power minus infinity is 0, putting 0 it is 1. So this is alpha by alpha square means 1 by alpha. Therefore the mean of the exponential distribution is 1 by alpha. Now coming to the variance of this distribution. What is the variance of this distribution? Variance, as you know, variance of x or your sigma square is expectation of x minus mu whole square is again your expectation of x square minus mu square. If you simplify it, so this will be equal to integral 0 to infinity your x square fx minus mu square. Mu you got it earlier, so this is equal to 0 to infinity x square alpha e to the power minus alpha x minus mu square. Likewise you integrate it, alpha taken outside, apply integration by parts here, x square e to the power minus alpha x minus 2x e to the power minus alpha x by minus alpha. Put a negative sign, put a positive sign here alternatively. So it is e to the power minus alpha x by, and 1 second. So you see the integral, first into integral second. So it will be this, the negative sign, derivative of first and integral of this, right? The derivative of this and integral of this. And again positive sign alternatively, derivative of this and integration of this. So now for your infinity this will not work, and for 0 also this will not work, it is 0. Similarly these two terms will vanish here. So it will be here alpha 2 taken out and minus of alpha q taken out. It is e to the power minus alpha x and minus mu square is there. So it is my 0 minus 1 and minus your mu. What is your mu? Mu is 1 by alpha, we will see. So this is equal to here 1 by 2 by alpha square minus your mu is 1 by alpha square. So this is equal to 1 by alpha square. So therefore your sigma square is 1 by alpha square. If you think of the standard deviation, it is sigma is 1 by alpha. So in a note we can say in exponential distribution, your mu is same as the mean is same as the standard deviation. Mean is equal to standard deviation is equal to 1 by alpha here, right? Coming to an important example. the length of a telephone conversation, right, has an exponential distribution. It is mentioned that the exponential distribution with a mean of 3 minutes. What is mu? You know mu is your 1 by alpha is equal to 3, implies what is your alpha? Alpha is 1 by 3, because in exponential distribution we need the parameter alpha here. Then find the probability that a call ends in 3 minutes, right? The call ends means the call lasts up to 3 minutes, right? Ends in 3 minutes. And secondly, it is asked, takes between 3 and 5 minutes, probability of 3 less than x less than 5, right? So these two things are asked here. So what is the probability function here? The probability function here is, what is the probability function here? Fx is alpha e to the power minus alpha x. Alpha is greater than is equal to 0. Here alpha negative time is useless here, so no need to mention that alpha it is an x greater than equal to 0. X greater than is equal to 0. X is time here, so no need to mention that it is 0 when x less than 0. No need to mention here. So we will work on this only, right, because negative time is useless here. So now coming to the first case, p of x less than 3. What does it mean? It means integral minus infinity to 3 alpha e to the power minus alpha x dx. Now it is again minus infinity to 3 is useless. It is minus infinity to 0 plus 0 to 3 f dx, alpha e to the power minus alpha x dx, right? So this is useless here. So this will give you integral 0 to 3 alpha taken out e to the power minus alpha x dx. You integrate it, it is alpha by minus alpha e to the power minus alpha x. It is here 0 to 3. So this is equal to, it is here minus 1 and e to the power minus alpha into 3 minus here 1. So this will give you 1 minus e to the power minus 3 alpha. The value of alpha is 1 by 3. So 1 minus e to the power minus 3 into 1 by 3. So this is equal to 1 minus 1 by e. This is e minus 1. This is here e minus 1 by e. If we put e is equal to 2.7182, then this will give you a value of 0.6371. 0.6371. Now coming to the second subbit, that probability of 3 less than x less than 5 means you need to integrate it from 3 to 5, right? 3 to 5 fx dx. You just integrate it 3 to 5 alpha e to the power minus alpha x dx. Okay, taking alpha outside, it is the integration of e to the power minus alpha x is e to the power minus alpha x by minus alpha from 3 to 5. If you solve it, then the integration will be this much, and we just simplify it, substitute the value here. The value of alpha is 1 by 3 we have substituted, and we get this is the outcome. This is the outcome, right? So now coming to one other example, coming to another important question. In a town, the duration of shower is exponentially distributed, it is mentioned. Otherwise, with mean 5 minutes. So mu is equal to your 1 by alpha is equal to 5. But we need alpha here. So this implies my alpha is 1 by 5. What is the probability that the shower will last for less than 10 minutes and more than 10 minutes or more? So what is the probability function here? Fx is equal to alpha e to the power minus alpha x, x positive. We no need of x negative here. right, and the value of alpha is 1 by 5. So this implies my fx is equal to my 1 by 5 e to the power minus 1 by 5x. Okay, so now the first question is probability of less than 10 minutes, x less than 10, right? So what does it mean? It means 0 to 10 alpha e to the power minus alpha x dx. So if you integrate it, so alpha by minus alpha e to the power minus alpha x 0 to 10. So this is equal to your minus 1 e to the power minus 10 alpha minus 1. This is 1 minus e to the power minus 10 alpha. So 1 minus e to the power, here value of alpha is 1 by 5 e to the power minus 2. Is not it? Similarly, if you substitute e is 2.7182, then it will give you the value 0.8647. Coming to the second question, probability that it will last for 10 minutes or more, probability of x greater than is equal to 10. So the properties of the distribution, it can be written as 1 minus p of x less than 10. If you write less than equal to, no issue. So now already this answer is, we got it here. So this is equal to 1 minus 0.8647. If you simplify it, it will give you 0.1353. Okay, so this is your final answer. Distribution is one of the most important distribution which has many applications in practical field, and it is a continuous type distribution. In our upcoming lecture we will see the normal distribution. Right? Normal distribution is one of the most important distribution, and it has many application in your statistical tests, right? Chi-square test, t-test, f-test, etc. So thank you all.